Okay, wait, this looks so bad. This actually looks so bad. The sensitivity is so low, too. Okay, this animation is like... Yeah, it's like really bad. Okay, I'm probably gonna have to build a thing from scratch. Fudge. I can't pick this up. I can't. This is it. This is literally the whole game. This is the whole base thing. Okay, seriously, what is this animation? I do like how... Okay, I mean, this is like kind of the type that I want. Kind of the type of 3D camera I want. And if I jump off... Okay. Um... Why did I think that was... nothing? Okay, the real question is, should I start with a 2D game? Or should I start with a 3D game? Like, learning-wise. Yeah, this jump animation is so scuffed. Like, who does that? Like, it doesn't even do a wind up or anything. It just... Oh, boot! My hands are in the air. Yeah, this is bad. This is really bad. Okay, I'm deleting this. I mean, it's like decent, but it's pretty scuffed. Alright. Okay, okay. Definitely looks like Genshin kind of camera. True. Okay, I'm not even talking to anybody. I'm not even answering your question, so I don't know why I said true. Okay, whatever. This is pretty bad. Alright. Yeah, time to not do that. Fudge, man. Really? I didn't mean to do that. Okay, I like don't... How do I delete this? I guess I just have to do that. Oh my gosh, how big is this? Alright, that's fine. So first off, we're gonna watch this video.
Specific tips. First off, scriptable objects. You should use them. Scriptable objects are complicated, but basically they are a great way to create everything from items to dialogue systems. And if you want more info on them, then I linked this great video on the subject by Sam Yam in the description. Using scriptable objects will simplify your game and also make it much easier to expand it.
This
So
is
I
like...
promise you, it is worth it.
This is like the whole point of the game, right?
Time investment to learn how to use it. It's worth mentioning because I didn't realize this for years, but you can actually make presets for import settings for audio and image files, which is great if you have a pixel art game, as it makes it so you don't have to turn off filtering for every sprite anymore. And also, it would have been helpful to know earlier that there are animation controller variants, which are basically like prefabs for your animation controllers. This allows you to have the same structure for the animation controller, but switch out the animations, which is great for things like guns and FPSs. And here we go. It's time to talk about what might just be the best part of Unity
know
other
what
than
that
the glorious
means,
particle
but alright.
system. The Asset Store. The Asset Store is full of great tools and assets that have saved me countless hours. So, what do I recommend? Well, there are a few assets and tools I consider essentials for making games. The first one is technically free and not actually on the Asset Store, but go ahead and download Easy Camera Shake off of GitHub. It's an incredibly simple to use way to handle camera shake. It works with multiple cameras and is overall just something that I use in literally every game project. This one is also free but on the Unity Asset Store. It's a must-have if you ever work with player preferences, which are basically a built-in saving system that Unity has that is designed for saving settings. This asset is called Player Preferences Viewer, and it does just what it says. It's super helpful and simple. And also something that I use for just about every 2D game that I make is called All-in-One Sprite Shader. Shaders are super confusing, so this tool is very nice to have as it allows you to create a ton of effects, and all of them without having to use the shader editor, which is a win in my book. Another great tool that is on sale right now is called Behavior Designer. I only recently got it, but it allows you to create complex AI using a visual interface. Another game dev YouTuber, Pinnacle, uses it for the AI in their game as well. It's really flexible and allows you to create everything from RPG bosses to FPS bots. It's on sale for 50% off right now, alongside a lot of other assets in the store. These assets are all on sale AI in their game as well. It's really flexible and allows you to create everything from RPG bosses to FPS bots. It's on sale for 50% off right now, alongside a lot of other assets in the store.
Okay.
These assets are all on sale because the spring sale is going on until April 29th, and most of these deals that are happening now won't return until much later this year. Unity was kind enough to sponsor this video, so if you use a link in the description of this video, then you can help support the channel. But I'm not advertising these tools specifically because Unity told me to. These are genuinely things I use in every channel. Another great AI tool is on sale right now.
Okay, Unity Asset Store. Sure, I spelled Unity wrong, I guess.
There are a few assets and tools I consider essentials for making games. The first one is technically free and not actually on the Asset Store, but go ahead and download Easy Camera Shake off of GitHub. Is
it in the link? Or is it in the description? Sure, Easy Camera Shake GitHub. Sure, let me just save that.
It's an incredibly simple to use way to handle camera shake. It works with multiple cameras and is overall just something that I use in literally every game project. This one is also free but on the Unity Asset Store. It's a must-have if you ever work with player preferences, which are basically a built-in saving.
Welcome to the John Henry Weston Show.
Gosh, dang it.
Welcome to the John Henry Weston.
That's
I started
not what
working
I
on my game
meant
Couch
to
Combat
do.
around 2 years ago. But 2 years is a lot of time that I use for just FPSs. And here we go. It's time to talk about what my store is full of great assets are, but go ahead and download cameras and it's overall just something that I use in literally every game project. This one is also free.
Player Prefs Editor. Player Prefs Editor? Sure. BG Tools? Alright. Sure. Add to my assets. Okay, thanks, sure. I don't know if I want to open that yet. Actually, how do I... Okay. Okay, I'm so confused. Okay, now since I did that twice, it's maybe effed up, maybe?
But on the Unity Asset Store. It's a must-have if you and also some asset is called Player Preferences Viewer, and it does just what it says. It's super helpful and simple. And also something that I use for just about every 2D game that I make is called All-in-One Sprite Shader. Shaders are super confusing, so this tool is very nice to have as it allows you to create a ton of effects, and all of them without having to use the shader editor, which is a win in my book. Another great tool.
Okay, does he not like say what it's... Does he not like link it? The ultimate introduction. Okay, that's like a basic... That's like a basic Unity feature, so I'm a little confused.
Shaders are super.
Whatever. Okay, all in one sprite shader. Oh, cool.
Super confusing, so this tool is very nice to have as it allows you to create a ton of effects, and all of them without having to use the shader editor, which is a win in my book. Another great tool that is on sale right now is called Behavior Designer. I only Pinnacle got it, but it allows you to create complex AI using a visual interface. Behavior Designer. I only recently
Behavior Designer.
got
I'll
it
probably
for the AI in their game as well. 50% off right now, along with it, and most of these deals. If you use a link in the description of this video, then you can help support the channel. But I'm not advertising these tools
I can come back to this video always.
specifically because Unity told me to. These are genuinely things I use that I haven't mentioned yet in development, and I think are very helpful for every Unity developer. And of course, aside the asset store that I haven't mentioned yet is, well, the assets. There are 3D models, skyboxes, sound effects, sprites, and all sorts of other things. These are incredibly helpful for adding to your game. Personally, I prefer to make most of my assets myself, but I still use many assets all the time like particle effects and skyboxes to spice up my game. I'm not very good at making particle effects or skyboxes, so the asset store allows me to cover up holes in my development that would otherwise require me to hire new team members or something, which would be much more expensive. A few of these asset creating companies that I've used before and can personally recommend are SYNCY Studios, who cover everything low poly, Pinwheel Studio, who have great shaders and skyboxes, and Sidearm
Oh, that was a sick cut.
Studios, who make tons of cheap, high quality sound effects that I use.
That was a sick cut, bro.
You are a writer, but writing novels is hard. You have to manage those sentences, characters, worlds.
Okay, and now moving
Shut up.
from Unity to the more general section of this video, I figured I would cover the thing that everybody has to start off doing. Learning. Game development is complicated to say the least, and even though game engines like Unity simplify and speed up development, they still have huge learning curves. So what's my advice? Well, it's pretty simple actually. Just make games. Personally, I started my game development journey in Game Maker Studio, but I didn't really get anywhere for the first year or so, just because I didn't really make stuff. I felt like I needed to know more before I could make games, and that's just not true. So don't worry about the uniqueness or even really the quality of your games at first. Just make them. And also I think the beginners place way too much importance on the choice of game engine. While I do agree that it makes a difference for individual projects and you should look into all the options, it was very easy for me to switch from Game Maker to Unity, and I've also made projects using Godot and with Fountain Engine. The workflow in all of them is pretty similar to Unity. I just found that Unity was personally the one I liked most and best suited to my project, so that's what I stuck with. Just remember that a game engine is ultimately just the tool, and the quality of games comes down to the skill of the people making it. The best place to learn game development is in game jams. Game jams are short competitions where you make a game in a short amount of time. They are great for many things, from learning a basic understanding of a game development to testing out gamer and mechanic ideas or learning a new tool or engine. Plus, they are just a ton of fun, and you end up with a nice little game to show for it.
That's
so when
pretty
starting to learn game
cool,
development in a
that
specific
one.
engine, what I found
That
works
old
best
game.
for me was starting off by just following a longer video series that walks me through everything. Brackeys has some of these, and there are tons on Udemy. And you can just basically look around and choose whatever one has the genre of game that you'd like to make. And after either finishing the tutorial series or just getting bored, I'd recommend just jumping into whatever game project you want to. Just keep the scope for this first project very small, like something you could finish in a month or so. Anytime you come across something that you don't know how to do, just look look it up. YouTube tutorials and forum posts practically have the answers to any questions you could possibly have. And although it takes a bit of time to learn, the API of your engine is a goldmine of information that is absolutely critical to be able to use. Finally, it's also worth mentioning that you will never stop learning game dev. While I no longer need tutorials for everything I do, whenever I'm doing game development, I always end up with millions of open tabs to the pages of the API and forums. And personally, I don't think that's an issue at all.
Fog.
One very important tip for learning game development and programming in general is to learn data abstraction. That sounds fancy, but it's really just organizing your code and saving time. Learn to use loops in order to avoid repeating segments of your code. Learn to use arrays instead of creating tons of numbered variables. Learn to create functions to simplify your code and make it more readable. Even if it takes a bit more time whenever you are programming, if you ever have to come back to your code and expand it, you will thank your past self for making an actual good code that is easy to read and easy to expand. If you go into a game with no plan, it might be fine to start out, but after a while you'll probably end up in an absolute mess with no idea what to fancy, but it's really just organizing your code and saving. Even if it takes a bit more time whenever you are programming, if you ever have to come back to your code and expand it, you will thank your past self for making an actual good code that is easy to read and easy to expand. If you go into a game with no plan, it might be fine to start out, but after a while you'll probably end up in an absolute mess with no idea what to work on next. The obvious solution here is just planning, but that's often easier said than done. It can be hard to visualize the steps that it takes to get to a completed game, but programs like Trello and Milano make it much easier. Trello is a program for organizing tasks. I've had it since day one of my current game project, and it is an absolute lifesaver. I have my tasks separated into different groups, ranging from bugs I have to fix to ideas I have to an overall roadmap for my project. It's honestly a lot of fun to organize tasks and plan for the future, and Trello makes it super easy to make major changes and plan really quickly as well. It's free and browser-based, and I'd recommend it for literally any project, but it's basically perfect for making games. Milano is a program that I only recently started using, and it's less about managing tasks and more about just planning out the future. Milano is super flexible and allows you to create mood boards, character charts, gameplay systems, and just about anything else you could possibly need for planning out your game. I'm currently using it to secretly prototype my next game idea, and that is where it really shines, so I'd recommend trying it out. Honestly, marketing might just be the hardest part of game development. It's one thing to make a game, another thing to get people to actually play it, and it's even harder to actually make money off of it. Although I don't know for certain if my game will actually do well as I haven't released it yet, I do have a channel that is largely dedicated to its development with just over 9,000 subscribers, and I have around 1,000 wishlists on Steam, so I think I have a pretty decent start. But I get that most people don't want to have to upload videos and maintain a channel while making their game. It definitely takes up a lot of time and effort on my part, but I do really like doing it, so it's worth it in my case. But there are many other ways that you can try to market your game and find an audience, and most of them actually start right at the beginning of development. First off, make sure you are making a game that people actually want. This means two things. First off, the game has to have appeal. Well, very specific and niche
Oh my
games
gosh,
can be
he
super
forgot a P. He spelled appeal wrong. Appeal. The word appeal. Oh my gosh,
successful.
never
If
mind.
your game is something that is straight up unappealing, like a game about filing taxes, then it's going to be 1,000 times harder to find an audience. You still might be able to, but it's worth thinking about. And the second thing is to make a game that hasn't been done a million other times. There are way too many generic 2D platformers out there to count. You can totally make a 2D platformer, it just has to offer something that other games just don't. So basically, if you want to have a successful game,
What
you
is
need to
this?
find a
This
niche
is Dead Cells,
you
right?
enjoy creating. In my case, I personally love split-screen multiplayer games, so I decided to focus on the very empty niche of split-screen FPS games for the PC. Once again, I don't know if my game will be a success, but I'm taking all the steps that I can to move it closer to being one. And another thing that you can do to advertise your game is just posting it to Twitter. I honestly don't really like Twitter, but many people have been able to gather audiences by showcasing the development of their games. This isn't easy though, as it requires consistent posting, uses of
This game looks sick, actually. What the fuck?
hashtags like Screenshot Saturday, and actually having an interesting game idea. But it's totally worth it if you can get people to buy your game. Also, posting on Reddit is totally an option. Motivation is an important part of game development, but I believe that it kind of comes naturally if you do the other things that I mentioned in this video. If you plan out and have a clear idea of what you want your game to be, and have an outline of the steps that you need to take to reach that final game, then you not only have a goal to strive for, but you also have tasks that you can always be working on. If you post on YouTube, Twitter, or wherever about your game, then it makes it way easier to stay productive and motivated. Personally, I end up working a lot more consistently on my game, that way I have cool things to put in my devlogs whenever I release them. Plus, for me, the feedback and the fake internet points make it a lot easier to stay motivated. But other than that,
True.
personally, I end up working a lot more consistently on
though.
my game, that way I have cool things to put in my devlogs whenever I release them. Plus, for me, the feedback and the fake internet points make it a lot easier to stay motivated. But other than what I've already mentioned, sometimes you just have to create your own motivation. You aren't always going to want to work on your game, and while you shouldn't constantly force yourself to work, the only real way to get out of a slump in development is to put the time in and, well, develop your game. Okay, we're almost done. I'm just going to finish with a few specific quick tips. Tip number 1 is that input management is horrible. At least that's the case for Unity.
Input management. Yeah.
Management is horrible. At least that's the case for Unity. So you should just go ahead and not suffer through bug fixing and changing systems 10 times, and either just use the new input system that Unity made, or buy Rewired from the asset store. The built-in input system doesn't work with multiple controllers. Well, the trigger buttons don't work with multiple controllers, which is about the stupidest thing ever. Just trust me on this. I know the new input system is confusing, but it's worth it. The other really big time sink for my game has been online multiplayer. So here's what I'll say. If you are considering adding online multiplayer to your Unity game, do it at the very beginning of development. If you design your game from the ground up for multiplayer, it'll be so much easier than trying to add multiplayer into a game 2 years into development. And you can trust me on that, it's not fun. Maybe other tools like to a game 2 years into development, and you can trust me on that, it's not fun. Maybe other tools like Unreal and Photon are better at integrating into already made games, but my personal experience with trying to add Mir into my project was an absolute nightmare that ended up in me losing over a month of work, so just be wary of it. So yeah, I really hope that this video helps save some people from possibly falling into the same pitfalls as I did. If you want to support my channel, the best free way is to wishlist my game Couch Combat on Steam. Wishlisting is free, and it really helps me since I don't have any marketing budget. The more people that wishlist my game, the more Steam will push it whenever I release it. So every wishlist counts. Thank you to Unity for sponsoring this video, and be sure to check out the spring sale for plenty of great deals. And thank you to my one and only Patreon, Howard House. He was
Patron. Why do people call them Patreons? Patreon is the fudging website. Okay.
unanimously voted as the best beatboxer in the world by everybody in the world. Bye.
Right. Which... Okay, let me look up... actually, let me make a new project first. 3D or 2D? You just look up Unity here. How to change the default script template? Okay. Oh, here. What am I doing? So let's just start from the beginning here. Okay, actually, this is a 2D game. This is a...
Did you know the
Okay, brother. Listen to this audio.
year, according to Indeed.com, that's $6,250 every single month. How much does your
What the fu- I don't even have acoustics that bad. Yikes, bro. Yike. Okay, this is also a 2D one. So I think I'm just gonna start with Sebastian Lag, or Lag. Whatever. And let's do, Introduction to Game Development, Unity and C#. Okay, is this like
Hi
a
everyone,
trailer?
welcome to this introduction to game development in Unity.
And how long ago was this? Oh, kind of a long time ago.
In this series, we're going to start out
But whatever.
by looking at the basics of programming in the C# language, and then continue learning more as we create games of
Oh,
increasing
that looks sick, actually.
complexity inside the Unity engine. Along the way, I'll also be providing some challenges for you to try complete on your own so that you can practice your problem-solving skills as a
Okay, so there are 25
programmer.
episodes. But that Pong? Wait, that
Hey,
actually
everyone.
looks sick. That looked super cool.
So, to give a rough outline of the series, I'm going to begin with several videos covering some important programming concepts such as variables, methods, and classes. Following this, there'll be a brief introduction to the Unity engine, after which we'll experiment with some practical examples of the things we've learnt. Once we have the basics down, we'll then finally be able to start creating games. And as we go through this process, I'll also be introducing new concepts to solve challenges as they arise. That's everything for this introduction. I hope you'll join me in episode 1. Until then, cheers. Hello everyone. In this first episode, I'd like to introduce two important concepts in programming, variables and methods.
Okay, I already know how to do this, kind of, so...
In our code, we need to be able to keep track of changing information, and this is
Okay, never mind.
where variables come in. So a variable is essentially a name to which we can assign some data.
Okay.
If we wanted it way,
Yeah,
then make a flash of light and apply, say, 10 damage to all objects within 5 units.
this is just like conceptualization right now. Alright. I
to
might
the variable.
actually not need to do this. But I just have to remember the format here. Public static void static. Okay, but it's not ever going to be static. I don't think. And it could return something else, but this isn't, this is gonna be string.
We can say
Yeah.
string
There
name
you go.
is return recap, a generate random name method. At all, or it can
Alright, sure.
operate. Hi everyone, welcome to episode 2. In the last,
Okay,
for example,
I
creating a class can be as simple
already know this. Let me just see if there's anything that I don't know
as
yet.
an aren't only thing is here we're trying to have eating and slurs, both mammal and in the mammal and live birth. Now if we want to have the same code in both classes, we could create a new class called animal, which has this common code in it. Both mammal and bird can then inherit from animal, meaning that they both get access to this functionality. In the mammal and bird classes, we can then focus only on bird. In our game, it could inherit from mammal live birth a trunk. Here, penguin instead is to split the class for simply combining the relevant components.
I forgot how to do inheritance, actually. Whoops.
So in you enable us to do this. Generally use classes functionality. One example is if we create a method named update, MonoBehavior will make sure that it gets called once every frame while the game is running. So say I create an enemy class, the colon after the class name indicates that this class inherits from MonoBehavior. Inside the update method, I might create a new variable called canCPlayer and set it to false. Then I'd have some code that sets canCPlayer to true if the player is within a certain distance. Finally, I'd have an if statement, which we'll learn more about later, to say that if the canCPlayer variable is true, then the enemy should attack the player. Called an instance.
Seems like a little bit of a convoluted way to do that. Do you want to go out, Kitani? Do you want to go out the room? Okay, my cat is here. And I don't know if she wants to leave the room because I closed the door.
Instance of the enemy class. Importantly, the variables inside the different instances can have different values. Another instance is variables. State class difference number of enemies alive, as well as a non-static is running. The value of number of enemies alive would be equal to 5, while the instance example variable would have a separate value of 1 for each of the 5 enemy instances. Let's say that I wanted to access the number of enemies alive variable from another class. First, we'd have to add the keyword public in front of it to make it accessible to other classes. But now in my
Number of enemies alive equals... Okay, sure. But this doesn't do anything. What?
other class, I could
confused.
access a name. However, if I wanted to know the value of the instance
This guy might not be the best teacher.
example variable, do you think I could do the same thing? The answer is no. In that case, the computer would ask, which instance of the enemy class do you want me to fetch the value from? And by ask, of course, I just mean that there would be an error. Hopefully this example has made the difference between instance and class variables clear. Note that the same concept of static and non-static applies to methods as well.
Oh, I guess if this was private, then this would only be 1. If this was public, that would be 5.
This leads us to way in which classes are used. Number 2, static classes. Making an entire class static has 2 main implications for us to consider. The first is that all of its methods and variables have to be made static as well. The second is that we can't attach this class to objects in our game, since static forbids us from creating instances of it.
And this is new.
On the other hand, as we saw with the number of enemies alive example, the restriction of making something static makes it very easy to access from other classes. Because of this, static is extremely well suited to what we call utility classes. An example of a utility class would be a static class called maths. Inside of this, we might define various things, for example, a static float containing the first 10 digits of pi, or a static method to calculate the square root of a given number. Once again, these are all made public.
Huh. What? Oh,
So
I
that
see.
from any
Never
other
mind.
class, if we want to know the value of pi, we just have to write maths.pi, or similarly, if we need to calculate the square root of a number, we can write maths.square root of that number. Alright, maths.
Some method x float x equals maths.pi. Sure.
Square root of that number. Alright, that's all the new information for this episode, so let's do a quick recap. Classes are used to group together related methods and variables. We can expand on the functionality of a base class, such as animal, by inheriting from it. Alternatively, we can have each class define a single behavior and build more complex composite behaviors out of these elements. When we attach a class to an object in our game, we are creating an instance of it that belongs specifically to that object. At runtime, values of the variables inside each instance can be different. The exception to this is if the variable is static, in which case it belongs to the class, not to any specific instance. Because of this, making variables and methods static is especially useful in utility classes such as a maths class, as they can then be accessed from other classes without having to get a reference to a specific instance. I hope you enjoyed the
Wow.
What's the first thing that pops into your head when I say Chip and Dale? I bet it's these guys! But certainly the second would be those rascally cartoon chipmunks, Chip and Dale. What if I did something?
What an effective ad.
Hello everyone,
The previous one.
welcome
Unity
to episode
overview.
Some classes window so that it sits next to the scene view, and I could do the same with the console window, so it's over here next to the project, And I might also just resize some of these panels, because currently they're taking up a lot of space.
Okay,
And then
cool.
if we want to save our custom layout, you can just go to the layout dropdown at the top right here and say save layout. I'll just call this my custom layout and press save. And of course we can switch back to default at any time we want. So the Unity editor is essentially made up of these 6 main panels: the hierarchy, the scene, the game, the inspector, the project, and the console. The hierarchy shows a list of all of the objects currently in our scene. At the moment, I have a camera object as well as a light source. If I were to add in a default cube, you can see that that would show up here, as well as in the scene view, where I can move it around, or by changing to the rotation tool in the top left, and of course rotate it and scale it. All of these things have shortcuts, of course. It's W to move, E to rotate, and R to scale. In the scene view, I can use the scroll wheel to zoom, can hold down Alt and left-click drag to rotate, and can middle mouse drag to pan the view. This little gizmo in the top right allows us to quickly switch between views, and we can also change between perspective and isometric modes by toggling this little cube in the center. The game window is where we'll see a preview of our game as viewed through the eyes of our camera object, and we can enter and exit play mode over here, although currently of course not much will happen since we haven't programmed anything yet.
Yeah, this might be going... He might teach a little too fast for me, to be honest.
The inspector shows us information about a selected object. Remember how in the last episode I spoke about composition, a way of building functionality out of multiple classes that each define a single behavior? Well, here we can see an example of that at work. Our cube has 4 components attached to it, all of which are defined by an object. Remember how in the last episode I spoke about composition, a way of building functionality out of multiple classes that each define a single behavior? Well, here episode I spoke about composition, a way of building functionality out of multiple classes that each define a single behavior.
A way of building functionality out of multiple classes that define a single behavior.
Building functionality out of multiple, a way of building functionality out of multiple classes that each define a single behavior.
Sure.
Well,
yeah.
here we can see an example of that at work. Our cube has 4 components attached to it, all of which
A single behavior each is what he meant, not a single behavior, single shared behavior.
simply
Okay.
classes that Unity has written and add
Whatever.
to this object to make it into a cube. If I remove the box collider component, it loses collision functionality, and if I remove the mesh render component, it loses rendering functionality. The transform component is what allows us to move the object around as well as to rotate and scale it. The project window contains all of the component is what allows collision functionality, and if I remove the mesh render component, it loses rendering functionality. The transform component is what allows us to move the object around as well as to rotate and scale it. The project window contains all of the assets for our project, so in a full project we'd have lots of scripts and 3D models, audio files, and so on listed here. We can drag things from our project window into our scene. For example, let me drag this simple Flash script that I prepared before the video into the project. If I now add this to the cube object, you can see that it pops up as a new component on this object. If we now press play, you can see the new behavior taking effect. It's worth getting used to the idea that while we're in play mode, our changes are not permanent. I might remove the script, for example, and change the position of the object, but as soon as I exit play mode, it reverts back to how it was before. This behavior is beneficial, however, as it allows us to try out new things while the game is running, without worrying about ruining our work. Finally, there is the console window. The console allows us to print messages from our scripts containing information about, for example, the value of a variable at a certain moment. This allows us to track down bugs in our code when things are not behaving as intended. It's also here that we'll receive error messages if we program something incorrectly. The last thing I'd like to mention is that we can have multiple scenes. So if I save the scene, and maybe call it cube scene, then I can go and create a new scene. In here, I'll make a sphere object, and then save it and call it sphere scene. Now I can switch between these two scenes by double-clicking on them. Obviously, there are also ways for us to switch between scenes using code during our game as well. So as you can imagine, this is very useful for when we want multiple levels in our game, or even just for separating things like the game menu from the game itself. Okay, so you hopefully now have an understanding of the broad elements of the Unity editor. In the next episode, we'll start applying everything that we've learned up to this point by programming some simple scripts. Until then, cheers. Hello everyone, in this episode we're going to be working a bit with methods and variables, basically just getting comfortable programming with them. So here in Unity I've got my custom layout set up from the previous episode. I'm just going to head over to the project window and right click, create new C# script, and I'll just call this something like episode 4, and we can double click to open that up in MonoDevelop. So this is the default text that we're faced with when we create a new script in Unity. Don't worry, by the way, if your colors are different from mine. This is just something that we can customize under syntax highlighting in the preferences, and obviously it doesn't change the way that the code behaves at all. So most of the things here you should be familiar with from the first few episodes. For example, we've got the class keyword followed by the name of the class, episode 4, and then the colon monobehavior we discussed means that it inherits from monobehavior, which just gives us some base functionality. For example, the start method, which gets called automatically at the start of the game, and the update method, which gets called once per frame while the game is running. Remember that the void keywords means that these methods don't return anything, and any text that follows a double slash on the same line is just a note that we can leave either to ourselves or to other programmers explaining what a bit of code does. The only things we haven't talked about are these two lines at the top here, which are called namespaces, and for the time being, we are going to ignore those. So to start with, I'd like to look at how we can print stuff to the Unity console. So monobehavior has a print method, so if we just write the word print, you can see the IntelliSense tool is going to give us some information about print. For example, it's a public static void, and it takes in an object for the message. We've got this little summary here as well, logs message to the Unity console, so that sounds like what we want. So if we open...
Okay, why did my stream just bug out?
parentheses, we now need to pass in an object, and it turns out in C#, we'll talk more about this later, but most things are objects. So for example, we can pass in a string, so let's just write start.
Sorry about that.
So just the word start inside of quotation marks, then close the parentheses, and remember to add a semicolon for the end of the line. Let's do a similar thing in the update method, print, open parentheses, let's print the word update, and close parentheses, semicolon. So now if we save, and go into Unity, we're going to want to attach this script to an object in our scene. So let's create a new empty game object and just drag that onto the object. You'll see it pops up in the inspector here. And then if we press play, you can see that this is being printed out into the console. If we just toggle collapse, then you can see a nice condensed view of it. And you can see update has been printed by now 500 times. So it's being printed every frame as we'd expect. Let's go back into our episode 4 class. And let's quickly discuss something called variable scope. So say I were to create a variable inside of a method. Let's take the start method, and I'll just create an integer variable, so int, call that x, and assign it a value of 0. What happens now is when this method is run, the integer x is created, but then as soon as the method has finished running, the variable x is destroyed from the computer's memory. Because of this, we'll only create a variable inside of a method if we want to temporarily store some information for use in a calculation, for example. We call x a local variable. It was created between this opening and closing pair of braces, so it is local. In other words, it can only be used by code which also exists between that same pair of braces. If I try access it from somewhere else, say the update method, x equals 5, we get this little error saying that x doesn't exist in the current context. So just to hopefully drive this point home, say I create an opening and closing pair of braces. This defines a new local scope. So I can still access x in here, x equals 5 for example, because this is part of the scope in which x was defined. However, if I create an integer y inside of here, I cannot use y outside of this pair of braces. If I did try, say, y equals 5 out here, for instance, we get the same error again because y no longer exists. So because local variables get destroyed at the end of their scope, we obviously can't use them to keep track of things across the entire game, such as the player's health. So what we can do instead is create a variable like that outside of any method, usually at the top of our class. Let's use the example of keeping track of the number of frames that have passed in our game. So I'll create an integer called frame count, and notice the convention for naming variables. We start with a small letter, and then each subsequent word starts with a capital letter. We can say frame count equals 0, and just to give a bit of terminology, this part where we give the name of the variable and the type of the variable is called the variable declaration. Here where we give it its initial value is called the initialization. When we're creating these non-local variables, the initialization is optional. If we leave this out, it will get initialized to its default value, which for integers is 0. So now to count the number of frames, we're just going to go into the update method, since that's called once per frame, and add 1 to the frame count. So we can say frame count is equal to frame count plus 1. Now there is a shorthand way of writing this, which is simply frame count plus equals 1. This is saying that 1 gets added to the original value. So you'll generally see this instead because it's of course much shorter. Let's now print out our frame count, so we can say frame count. Then let's save this and go into Unity to run it. And we can see that now our frame count gets printed out over here. If we wanted to print the words frame count next to it, we could add quotation marks, frame count, and then we just say plus. So the plus operator is not only for numbers, we can also add things onto strings. So here we're adding the value of frame count onto this frame count string. Let's save that and run. And you can see that working in the bottom right here. Alright, so we briefly touched on variables. Let's now take a look at a practical example of a method. So say we want a method to calculate the distance between 2 points. So if we're given 2 points defined by the coordinates x1, y1 and x2, y2, we can of course use Pythagoras' theorem to find the distance. So we'd say the change in x, or delta x, is equal to x2 minus x1.
Yeah, we can use Pythagoras' theorem. Not the Pythagorean theorem. Just Pythagoras. Pythagoras' theorem.
1, and the delta y is equal to y2
Bruh.
minus y1, and then the distance is the square root of delta x squared plus delta y squared. So in our code, we'll want this method to return the value of the distance,
Okay.
so we'll give it a return
Nice calculus terminology, but
type of float, and then we can call this method something like
whatever.
get distance between 2 points. Notice the naming convention for a method here. It's exactly the same as variables, except the first letter is a capital. You might wonder why Unity hasn't followed this naming convention for their print method, and I'm not sure, but don't use that as an excuse to not follow the convention yourself. Let's now create our opening and closing parentheses, followed by the opening and closing braces. So we'll want to pass the coordinates of the 2 points into this method, so hopefully remember we can declare the not follow the convention yourself. Naming convention for exactly the same as variables, except the first letter is a capital. You might wonder why Unity hasn't followed this naming convention for their print method, and I'm not sure, but don't use that as an excuse to not follow the convention yourself. Let's now create our opening and closing parentheses, followed by the opening and closing braces. So we'll want to pass the coordinates of the 2 points into this method, so hopefully remember we can declare the variables inside of these parentheses here. So we say float x1, comma, float y1, and then for point 2, we'll say float x2, comma, float y2. So now we can create a local variable, delta x is equal to x2 minus x1, and float delta y is equal to y2 minus y1. So next we'll want to create a float called something like distance squared, and set that equal to delta x times delta x plus delta y times delta y. Alright, so we've got the squared distance. In order to get the actual distance, we now want to get the square root of distance squared. So to get the square root, we can use something called mathf, which, as you can see over here, is a struct, which we haven't learned about yet, but in this case it behaves pretty much identically to a class. So this has a method called square root, which, as you can see from this pop-up, takes in a float f and returns the square root of that number. So it's returning a float, so we can set our float distance variable directly to the result of this method. So mathf.square root of distance squared. Alright, all we need to do now is return the distance, so we write the return keyword, followed by distance, and as always, don't forget the semicolon. Alright, so now, say in the start method, we wanted to set float distance equal to, we can say get distance between 2 points, and it's generated this little pop-up for us, saying that this method returns a float, takes in x1, y1, x2, and y2, and we can pass in, say, 0 and 5, and then our second point could be 10 and 15.
Did he just say not? 0? He just called 0 not?
And just like that, we found the
Oh, this guy's very formal.
distance. Let's print it out. So print distance. All right, let's save and see what that distance happens to be. Let me just comment out this print frame count line, otherwise that's going to get lost in a wall of text. So just remember to save, of course, and then press play. So that distance happens to be 14.14214. Before we end off for this episode, I'd like to give an example of what happens if we make a mistake in our code.
Let me just think. 0, 5, and then 10, 15. So that would be here. Oh,
Say, for example, I forget the semicolon
Alright,
at the end of this line.
I guess
So
that's
delete
fine.
that, save, and go into Unity. You can see this error message pop up in the console saying unexpected symbol, float. And if we double click on the error message, it will take us to where the error is occurring. Now, the reason it's saying unexpected symbol float is it doesn't really care about paragraphs. It's reading this as being one line, and this doesn't make sense. Delta x times delta x plus delta y times delta y float. You can see why the float symbol was unexpected. It doesn't make sense here. So from this, we can figure out that we need to add the semicolon after delta y so that it knows that the line ends there. So that's one example of an error that could occur. Let's look at one more example. Say we forget to make this a float, and instead we say that it's a void method, but we're still trying to return the distance. If we now save and go into Unity, we can see that we actually have 3 errors now, but they're all being caused by the same thing. So we always start with the topmost error message, and we can see this one saying, cannot implicitly convert type void to float. Let's double click on that, and it says the error is coming from here because we're trying to set a float variable equal to a method which returns void. So from that we can immediately tell that this should be a float, and if we save and go into Unity, of course, all 3 of those error messages have now disappeared. Alright, that's everything for this video. I encourage you to practice what you've learned of methods and variables so that you can get comfortable working with them. Until next time, cheers.
If you're trying to create a game, do not learn how to code. That may seem very backwards to a lot of you guys, but
Bruh.
if you
Hello everyone, in this episode
Thanks.
we're taking a look at operators and conditional statements. So you're already familiar with some of the arithmetic operators. For example, we use the plus and minus symbols for addition and subtraction, and then the asterisk for multiplication, the forward slash for division, and the percent sign for the modulo operator. In case you're not familiar with modulo, it's essentially the remainder operator. So 10 mod 3 is equal to 1, for example, because 3 goes into 10 3 times with a remainder of 1. We often use this to check if a number is even, because any even number mod 2 will be equal to 0. A little more exciting, however, are the relational operators. First up, we have the equals operator, written as two consecutive equal signs, not to be confused, of course, with the assignment operator, which is just a single equal sign, as in int x equals 3 or int y equals 8. If we wanted to compare these two values, that's when we'd use this relational equals operator. So if we write x double equals y, we're stating that x has the same value as y, and if the statement happens to be correct, then a value of true will be returned, otherwise it will return false. So if we wanted, we could store the result in a bool variable. In this example, x is of course not equal to y, so bool a will be set to false. The next operator is the not equals operator, written as exclamation mark equals. We could make a bool variable called b and set it to the result of the statement x not equals y. Here b will of course be set to true because the statement is true. The same idea applies for the rest of the relational operators, greater than or equal to, less than, and less than or equal to. Now that we can compare values, we need a way to be able to run different code depending on the outcome of the comparison. We can do this using a conditional statement. For example, if x equals y, then run the code inside the braces. Take note of the notation. We have the key than or equal to, less than, and less than or equal to. Now that we can compare values, we need a way to be able to run different code depending on the outcome of the comparison. We can do this using a conditional statement. For example, if x equals y, then run the code inside the braces. Take note of the notation. We have the keyword if, followed by a pair of parentheses containing the condition, and then a pair of braces containing the code to run if the condition is true. I'd just like to point out that since we have this bool a, which is equal to the result of the statement x equals y, we could have the condition of our if statement be simply a. If a is true, then the if statement will run. Now we might want to run a different block of code if the condition turns out to be false. We can do this using the else keyword. It's also possible to add a new condition onto the else statement by saying else if. So here we're saying, if x is equal to y, do this. Otherwise, if x is greater than y, do this instead. Finally, let's add our else statement back on. So if none of the above were true, then resort to doing this. Alright, there are just three more operators I'd like to take a look at for now. These are called the logical operators, and they are AND, represented by two ampersand symbols, OR, represented by two vertical bar symbols, and NOT, represented by a single exclamation mark. So say we have two new bools, a equals true and b equals false. Now the statement if a and b will only run if both bools are true. If a or b will run if either a is true, or b is true, or both of them are true. And finally the statement if not a will only run if a is false. Okay, that's everything for this video.
I just forgot. Never mind.
The next one we'll practice using what we've learned here to detect input, among other fun things.
I always forget those. I always forget those ones.
Who becomes a Twilio developer? People who code as a side hustle. People who lead big development teams.
What is Twilio, bro? What the fudge? Whatever.
I'm going to be creating a little game to practice some of the stuff that we've learned up to.
Actually, let me look that up. What is Twilio? Oh. That makes sense.
To this point. So how the game works is the computer will print out a random number of seconds, and then you have to sort of count down those seconds in your mind, and when you think the time's up, you hit the spacebar, and it tells you how you did. Okay, so in Unity, I'm just going to head over to the project window, and right-click, create new C# script, and I'll call it something like time game. And then maybe we can just quickly create a new empty object in our scene, and just add the time game script to that.
Or you could just add it to the camera.
So before we get started...
But, sure. Okay, this is 16 minutes. This is 16 minutes. Alright, actually, I will do that tomorrow. So, thank you guys so much for watching this stream. Thank you for spending your most valuable resource, the time in your life, on watching this stream. And have a good one.